Hello everyone, it's time for another video with Mr. Tom and STEM Kids in Space! Today's topic, we're going to have two topics. They are drag and center of gravity. Here's another thing we can do for drag. Have you ever been in a car and you're able to roll down the window, stick your hand up while the car's moving, and you go like this with your hand. And when you hold it like this, there's more pressure, there's a lot of drag, a lot of more force. If you rotate it, your hand slices through the air, less drag. Maybe if you keep rotating it at an angle, now it's going to push down. Or if you're holding it like this angle, it goes up. Those are fun activities to try. Another activity similar to that is, instead of holding your hand flat, hold it in a ball. Now rotate it with the wind blowing against it. Not as much difference. There might be some because this is not a perfectly shaped ball. But it makes a difference. These are the type of choices that engineers have to make. What if you can't put your hand out in the car? That is quite possible. You may have a fan at home. You could turn the fan on, put your hand in front of the fan, not in the fan. You can feel the air blowing, do the same thing. Rotate your hand. Rotate a fist. What happens if you have your hand and open your fingers? How does that change? Well, we've talked about a rocket going up in the air. What about when the space capsule comes back down? Have you noticed that one side is kind of flat? Rotate it a little bit. What keeps the space capsule, when it's coming down, from rotating around and going this way? Well, there's a lot of science involved in that. Figuring it out, testing it. This curve here is designed just perfectly. The weight, the center of gravity, is put in here just right, so it's going to keep falling this way and at the right angle. So what comes down is going to be right. And there might be some thrusters on here to help guide it through. At some point, a parachute comes out, comes down, drag. Parachute up here, capsule down here. So that was several activities that you can try. You may need to get permission to access certain things. Let's try one more. Have you ever made a paper airplane? Take your piece of paper, fold it in half on one end, fold down the sides at 45 degrees, bend over each side so these edges are parallel. Then we're going to come down part way and fold it so that this edge is parallel to the bottom. Our paper airplane kind of looks like an airplane, not really like a rocket, but there are some airplanes, some planes that will go up into space. Well, we've got a center of gravity somewhere. We've got some drag, all designed so this will fly forward. We've also got some lift under the wings. We haven't talked about that. And we've also got gravity pulling down. All those forces work in such a way that it flies forward. You can stand somewhere, practice with a certain amount of force, throwing it maybe at different angles. Some people like to put little ailerons on these to help. But try different angles. See how far it goes. You've probably done that before, maybe, perhaps. What if we turn the airplane around and now throw it? How is it going to fly? Will it fly at all? Maybe when we turn it around, there's more drag in front and an airplane wants to rotate around. It may just fall looking for its center of gravity. working against the air resistance and various forces to come down. Try different angles. Are all of these tosses shorter than this way? Let's try another example. Take your piece of paper, fold it in half long ways. Now let's take each side and fold it down to the edge. So we've got wings, just like in their airplane, but it's all the same. Throw this one. How does it go? Does it go farther? Does it not go as far? Try different angles. Here we can get some lift because the air is blowing against our wings, and just like with our hand, so there's a resistance, it might go up, maybe not. Let's try something else with this one. Now let's cut the end just a little bit. Cut down the center. And we're going to take this leading edge and fold it over a couple times. I needed to cut a little bit farther, so I tore it. It's all right. Bend those over. So now I have the same design, but there's more weight in the front. How is this going to fly? How is it going to fly when I throw it with the extra weight in the front? Turn it around, throw it this way. Now how does it fly? Which way does it like better? These are some experiments that you can try with drag and center of gravity. That's it for this video. Keep enjoying space. Until the next video, this is Mr. Tom and STEM Kids in Space.